Hello students, in the last class we had studied about the two types of chemical reaction, that is combination reaction and decomposition reaction. Now we will be studying about displacement reaction. Okay, so the third type of chemical reaction, that is displacement reaction. Displacement reaction means the reaction in which there is occurring displacement of one element by another element. Okay, that is the displacement reaction. In this, the element which is more reactive displaces the less reactive element. Okay, so such type of reaction can be either between the metal and its salt solution and the salt solution of any metal, or salt solution of a non-metal with any more reactive non-metal. So we'll see some examples, then it will be more. Generally we can represent a displacement reaction in this way. Suppose the compound AB, when it reacts with a more reactive element C, then it will form AC plus B. Here C, it is more reactive element, and this is, here AB is the of less reactive. The order of more reactive and less reactive is according to the series, the reactivity series of metals. Okay, according to that we have to see which metal is more reactive and which is less. Okay, so the more reactive metal will be able to displace the less reactive metal from its salt solution. Here we see that as C is more reactive element, what will happen? It will displace the lesser reactive metal, that is B. Here the lesser reactive element, I can say it is B, and it will displace B from its salt solution and it will form salt, that is AC, with formation of B. B will be formed and the compound that will be formed is AC. So this we will study with the help of some examples. If you want to define a displacement reaction, then you can see the definition. Reaction in which more reactive element displaces lesser reactive element from its salt solution. Here displacement reaction, it can be categorized further into two types, that is single displacement reactions and double displacement reaction. Now the type of reaction we are studying, that is displacement of a lesser reactive metal or element from a more reactive element by a more reactive element, is the type of single displacement reaction. Okay, this is the type of single displacement reaction. Okay, now single displacement reaction, it is also known as single replacement reaction. The second or another name for the single displacement reaction is single replacement reaction, as the more reactive element is replacing the lesser reactive element. Now how can this occur? This can occur by two ways. First is when a more reactive metal will displace a less reactive metal from its salt solution. Second, when a more reactive non-metal. Now in this category we'll see some examples also. For example, copper sulfate solution. Okay, when it is there in a beaker and we immerse zinc rod, then what will we see that the copper sulfate, which is blue in color, becomes colorless. Okay, and there is some deposition of reddish brown substance, that is copper which is getting deposited. Okay, and the colorless solution is due to the formation of zinc sulfate. Here we see copper, it is lesser reactive than zinc, and so it is displaced from its salt solution. So students, today we are going to deal with the new type of chemical reaction, that is displacement reaction. In the last class we had studied about the combination reaction and the decomposition reaction. Okay, so the third type of chemical reaction, that is displacement reaction. Now the displacement reaction, it can be categorized further into two types, that is single displacement reactions and double displacement reaction. Okay, now the single displacement reaction are the reactions in which only the displacement occurs one time, that is only one element replaces the other element. Okay, suppose here a compound AB reacts with an element C, then it will form AC and B. Okay, so here we see that C is replacing B. Okay, that is B is being replaced by C. So this single displacement reaction is also known as single replacement reaction, because here we see B is being replaced by C. Okay, and this replacement, as it happens one time, so the name is given single replacement or single displacement reaction. Whereas in the case of double displacement reaction, we will see that there are two compounds AB plus CD. Here the formation of AD plus CB will occur. We see here C is displacing A. Okay, and at the same time A is taking the place of C. Okay, so this type of reaction in which the ions or atoms are taking place of one another, okay, these are known as double displacement reaction or double replacement reaction. Okay, so first we will be studying single displacement reaction, its various some examples of these types of reaction, and then we will see the double displacement reaction. Okay. Single displacement in single displacement reaction, we see that the more reactive element displaces or replaces the less reactive element. Okay. Now this can be explained by the following examples. For example, in the first category, we see the displacement of less reactive metal by a more reactive metal from the salt solution of less reactive metal. For example, CuSO4, that is copper sulfate, aqueous solution is blue in color. Okay. When it is reacting with zinc pieces, okay, when I add zinc pieces to it, then what will be seen that the color of the solution is changing due to the formation of ZnSO4, that is zinc sulfate. Okay, the solution has now become colorless and there is deposition of some brownish reddish compound, that is copper. So in this we can see that zinc is displacing copper from its salt solution. So we can say here that as zinc is more reactive, so it displaces the lesser reactive metal from its salt solution. Okay. Similarly, we can see some more examples of this kind of displacement. Reaction of zinc chloride aqueous solution with it will form AlCl3 and zinc will get separated. Okay, so here we see as aluminium is more reactive than zinc, so aluminium will displace zinc from its salt solution, and here there will be a formation of salt, that is aluminium chloride. Okay. So this is the type of reaction in which we see that the more reactive metal is displacing the less reactive metal. The second category we can take is the displacement by a non-metal. Displacement of less reactive non-metal by a more reactive from salt solution of less reactive non-metal. So here we'll see that the less reactive non-metal is displaced by the more reactive non-metal from its salt solution. For example, reaction of potassium bromide, okay, KBr, aqueous solution with chlorine. When chlorine gas is bubbled in the KBr aqueous solution, then what we will see that there is formation of KCl and brown fumes of Br2, that is bromine is bubbled out. Okay, so bromine gas, it is released in the formation of KCl, that is potassium chloride. Chlorine being more reactive than bromine, so it displaces bromine from its salt solution. So this is how we can show that a more reactive non-metal is displacing the less reactive non-metal. The order of the non-metal reactivity for halogens, we can see that fluorine is more reactive than chlorine, which is more reactive than bromine, which is more reactive than iodine. Okay, so chlorine will displace bromine and iodine from their salt solution. Okay, but bromine will not be able to displace chlorine from its salt solution. Another example we can take is reaction of NaCl with iodine. Will the reaction proceed? Here, as iodine is less reactive, so it will not displace chlorine, and so this reaction will not proceed. And we see if the salt solution, that is salt of iodine, that is NaI, if it is taken and then we pass through it chlorine gas, then there will be formation of NaCl and iodine. This is how we can show the displacement of the more reactive nonmetal. This is how we can show the displacement of less reactive nonmetal by a more reactive nonmetal. Okay. The third type of displacement reaction is reaction of metals above hydrogen with acids. Okay, this is also a category of displacement reaction. For example, magnesium, okay, when it is added to hydrochloric acid, that is HCl, dilute solution, then we'll see there is formation of MgCl2 and here hydrogen gas is liberated. So we can say here that hydrogen is being displaced by magnesium. Okay. So this is also a type of displacement reaction where the more reactive metal which is placed above hydrogen in the reactivity series, they can displace hydrogen from the acids. Okay, acids such as hydrochloric acid, sulfuric acid. Similarly, we can take another example. For example, ZnSO4, Zn solid, when it is treated with H2SO4 dilute solution, dilute H2SO4, then it will form ZnSO4 plus H2 gas is liberated. Okay, so in this case we can say that there is the displacement of hydrogen by a metal, okay, which is more reactive than it. So these are the types of single displacement reaction. Now we will see the double displacement reaction. Double displacement reaction, these are also sometimes known as double decomposition reaction. Okay. Now double displacement reaction, here there is displacement of two atoms of ions. They take their places of each other, or we can say that they exchange their places, okay, leading to the formation of new product. This is known as double displacement reaction. There is exchange of ions between the reactant molecules, leading to formation of new products. So as I told you, here A and B reacts with C and D. They will lead to the formation of AD and CD. Okay, here A and C, these are cations, so their positions are exchanged, and B and D are anions. So we can say that the cations have exchanged their position or the anions have exchanged their position, either of it. Okay, now if cation is exchanging their position, then C is taking the place of A and A is taking the place of C. Okay, whereas if we say that anions have exchanged their position, then B will take the position of D, okay, and D will take the position of B. So this, because there is occurring exchange, that is the displacement is happening two times, so it is said to be double displacement reaction. Now the double displacement reaction, these are also known as salt metathesis reactions. Okay, sometimes the word also used for this type of reaction is salt metathesis, because the compounds here, they both are salts and there is happening metathesis of the salt, that is there is exchange taking place, so the name is salt metathesis. Now we'll take some examples for this category. This double displacement involves the reactions, that is two types of reaction, that is either precipitation reaction or neutralization reaction. Neutralization will be our next category. We'll study the precipitation reaction in this category. Precipitation reactions are also double decomposition reaction or double displacement reaction. Here we will see some example of precipitation reaction. For example, we can say reaction of AgNO3 with NaCl solution. Here there will be formation of AgCl and NaNO3. Here we can see that Ag is taking the place of NaCl and NaCl is taking the place of Ag. So this is a double displacement reaction. Okay. Here they are aqueous solution, they react with each other and there is precipitation of AgCl. Okay. So here we can say there is precipitate formation of AgCl and NaNO3 is the aqueous solution. Okay. So this is a type of precipitation reaction. Another example we can take is the reaction of lead nitrate with potassium iodide solution. This will lead to the formation of lead iodide and potassium nitrate. Okay, so this is again a double displacement reaction. Here potassium is displacing lead and lead is displacing potassium. Okay, so this is again a double displacement reaction. Another example in this type of reaction is reaction of Fe2O3, that is ferric oxide. When it reacts with hydrochloric acid, that is HCl, it will form FeCl3, that is ferric chloride and water. Okay, here there is a gelatinous precipitate, we can say of greenish color settles down. Okay, this is ferric chloride. Here the precipitate of FeCl3 is formed. So this is also double displacement reaction. Iron is displacing hydrogen and hydrogen is taking the place of iron. So these are some examples of the precipitation reaction. Precipitation reaction, it is also called as aqueous metathesis. Okay, precipitation reaction is sometimes also told as aqueous metathesis. One more example we can take: reaction of BaCl2, that is barium chloride aqueous solution with copper sulfate solution. Or we can also take here sulfuric acid. It can also react. Here there will be formation of BaSO4. This white precipitate of BaSO4 will be formed, and copper chloride aqueous solution. Okay, barium chloride. Okay, so this is how we can show some examples of a double displacement reaction. Here barium is displacing copper and copper is displacing barium from its aqueous solution of the solvent. So these are some types of double displacement or double decomposition reaction. Now we will be studying the next type of chemical reaction, that is neutralization reaction. It is a specialized type of double displacement reaction. Neutralization reaction. Neutralization reaction, you can say that these are special type of double displacement reaction. Okay, now what do we mean by neutralization reaction? As the name suggests, neutralization, that is the process to make a solution neutral. Now when an acid is added to a base, it becomes neutral. Okay, now it becomes neutral. This is due to the formation of salt and water. Salt is formed, and this process involves a lot of release of heat or energy, you can say. So this is a type of reaction in which it is exothermic. The neutralization reaction are exothermic reaction, where we see acid and base react to form salt and water with the liberation of heat. Okay, so what happens here in acid base reaction? We can say that the base is having OH. Okay, and if I write the acid HA, here H is showing that it is H plus donor, that is it is an acid. Here H will combine with OH, okay, and it will form water. So H is taking the place of B and B will be taking the place of H. So again it is a double displacement reaction. Okay, so here we can say it will form Ba plus H2. Here Ba is a salt, okay, where the cation of the base and the anion of the acid, they form salt with the formation of water, and large amount of heat is liberated. So these are general representation of a neutralization reaction. So here we see that the radicals are exchanged. Okay, either the cations are exchanged or you can say the anions are exchanged. Now we'll see some examples of the neutralization reaction. First is reaction of NaOH with dilute sulfuric acid. It will form salt, that is Na2SO4 with the formation of water and heat. Okay. Na2SO4 is sodium sulfate. Okay. NaOH, sodium hydroxide. And H2SO4 is sulfuric acid. Okay. Another example is reaction of QH with HCl. This dilute. It will form KCl and water with the release of heat. Okay. Here we are seeing strong acid-base reactions. Okay. Strong acid and strong base are reacting to form salt and water. Here QH, that is potassium hydroxide. There is exchange of ions. Here potassium is taking the place of hydrogen and hydrogen is taking the place of potassium. Okay. So here OH from the base and H from the acid, they combine and they form water. Okay, so this we can say that OH and H plus combine and form water, and the positive radical and the negative radical which are left, they form the salt. In this case, the H plus and Cl minus, they combine and they will form an ionic compound, that is potassium chloride, that is the salt. So here the products of an acid-base reaction is acid plus base. It will form salt plus plus heat. So neutralization reaction are exothermic reactions. Okay.